Welcome to the presentation on the spatial analysis of rat presence in their student housing areas at Makassar State University. This research was conducted by a team from the Department of Environmental Health, Faculty of Public Health, Fajaruddin University. We will discuss the types of rats found, the environmental factors influencing their presence, and the spatial analysis using the buffer and area techniques. Rats are vectors of disease such as yersiniosis, leptospirosis, and salmonella, which can pose significant risk to human health. This issue frequently arises in student dormitories due to poor sanitation, inadequate waste management, and high population density, which attract rats. This student aims to spatial analyze rat movement using buffer area techniques and to correlate environmental factors in their dormitories, providing valuable insights into rat control efforts in educational settings. The research employed a descriptive observational methodology conducted from April to September 2021 in the student dormitories of State University in Makassar City, Unhas, UNM, and UIN. The study utilized accidental sampling techniques by setting up a total of 135 rat traps over 4 consecutive days at each location. Data collection involved direct observation of rats caught in the traps as an initial step to understand the distribution of rat population within the dormitory environment. Data analysis was performed using SPSS software for statistical processing, while spatial analysis was carried out with QGIS software employing buffer area techniques. This process aimed to determine the pattern of rat movement and the environmental factors influencing their presence. Through this approach, the study seeks to provide a detailed understanding of the relationship between rat presence and the condition of student dormitories, serving as a foundation for effective rat control measures. The rat trapping results over 4 days in the dormitories of UNM and Unhas yielded a total of 29 rats. Among these, the most commonly captured species was Rattus norvegisus, accounting for 20 individuals or 69% of the total catch. This indicated the dominance of the species in the dormitory environment, potentially due to environmental factors and the species' tendency to thrive in areas with sufficient food availability and shelter. Additionally, that other species were identified: Rattus tenacity with 5 individuals, and Rattus argentifenter with 3 individuals, and Rattus exos with 1 individual. This variation reflects the diversity of rat species in the study location, which may be influenced by the unique ecosystem condition of each dormitory. These data are critical for understanding the distribution of rat species and can inform development of more effective control strategies tailored to the characteristics of the species. The Rattus norvegisus, commonly known as the Norway rat, is one of the most frequently encountered rodent species in urban environments, including sewage systems and residential areas. This species demonstrates exceptional adaptability to human-dominated settings, often become the dominant species in areas with abundant food and shelter. Understanding its physical characteristics is essential for studying its behavior and devising effective control measures. These physical traits of Rattus norvegisus include a body length, head to tail ranging from 300 until 400 mm, with a tail length of approximately 170 until 230 mm. Its dorsal fur is dark brown with blackish tones, while the chest and belly are gray. Additionally, the height foot length is between 42 until 47 mm, and the ear length ranges from 80 until 22 mm. This information aids in the visual identification of the species, which is crucial for research and population control efforts in specific environments. The Rattus nasumi, commonly known as the house rat, is frequently found inside buildings such as attics, rooms, and kitchens, as well as in offices, hospitals, schools, and warehouses. Unlike the Rattus norvegisus, this species is small in size and more likely to interact directly with humans due to its habitat being primarily indoors. Its high adaptability to human environments makes it one of the most common rodent species in urban areas. Physically, the body length of Rattus tenacity from head to body range from 220 until 370 mm, with a tail length of approximately 101 until 118 mm. The dorsal will vary from dark brown to black, while the ventral side is dark brown or gray. Its height fin measure between 20 until 39 mm and its ears are 13 until 23 mm long. This information is crucial for identifying a species, understanding its behavior, and designing effective control strategies. Spatial analysis of rat movement was conducted using the buffer area techniques in this analysis. The area was divided into several zones based on the buffer distance from the rat traps. The 30-meter buffer zone was identified as high-risk area for rat presence, as this distance represents the minimum daily movement range of rats in search of food and shelter. This zone reflects area with the most intensive rat activity, typically around the trap location. The 60-meter buffer zone was categorized as a moderate risk area. This distance approximates the maximum average daily movement range of rats, indicating less frequent activity compared to the 30-meter zone beyond the 60-meter buffer zone. The risk of rat presence is considered low due to the greater distance from their primary activity centers. This approach provides valuable insights for identifying priority areas for rat control measures based on the risk level in different zones. The presence of waste significantly impacts rat movement. Analysis shows that areas with scattered waste are often within the buffer zones of rat movement, indicating a high risk of rat presence in those regions. Waste, particularly organic waste, serves as a primary attractant for rats by providing a consistent food source. Rats tend to move within buffer zone from one location to another in search of food, and poorly managed waste becomes a key factor driving this activity. In addition to being a food source, fields of waste often serve as netting sites for rats, offering the protection they need to survive. This not only increases the rat population in the area but also heightens the risk of disease transmission from rats, such as leptospirosis and salmonella. Therefore, effective waste management and regular cleaning of the area are critical to reducing its attractiveness to rats and minimizing associated health risks. The activity of rats is significantly influenced by temperature and humidity. Analysis indicated the rats are more active in environments with an optimal air temperature of 30 until 32 Celsius, which is considered terminatural for their bodies to perform daily activities. At this temperature range, their physiological function operate efficiently, enabling frequent movement in search of food and shelter. This highlights the substantial impact of environmental temperature on rat presence in given area. Moreover, the ideal humidity range of forest activities between 45 until 65%. This range supports their physiological function and it influences their movement. Environment with a combination of optimal temperature and humidity tend to pose higher risk of rat presence. Therefore, understanding environmental conditions such as temperature and humidity is crucial for predicting and managing rat population in specific locations. The measurement of temperature and humidity around the traps at the three student dormitory location, Lulhaq and Anugerah, reveal variation in environmental conditions that may influence rat activity. At Lulhaq is 88% of the area had optimal temperatures with 46 showing optimal humidity, indicating favorable condition for rat activity. At UNM, optimal temperatures were found in 82% of the area, but optimal humidity was only 4%, suggesting that lower humidity may impact rat activity. Meanwhile, at Unhas is 73% of the area had optimal temperatures with 26 showing optimal humidity. These variations highlight the role of optimal temperature and humidity in influencing rat presence. Location with a combination of temperature and humidity closer to optimal conditions tend to exhibit higher rat activity. This information is crucial for understanding the relationship between environment condition and rat population at each location, providing a basis for implementing more activity for more effectivity and location-specific rat control strategies. The relationship between air temperatures and the number of rats caught in the three student dormitory areas UIN and has indicated a clear correlation. UIN recorded the highest number of rats caught, which aligns with its having the large proportion of optimal temperature for rat activity. These favorable temperatures likely promote greater rat movement, increasing the likelihood of capture in this area. Conversely, Woodhouse had the lowest number of rat calls, corresponding to the lowest proportion of optimal temperature at this location, with an M in the middle, with moderate numbers of rats called and a majority proportion of optimal temperatures. This correlation underscores the significant role of air temperature in influencing rat activity and presence. These findings provide critical insight for designing control strategies tailored to the environmental conditions of each location. The presence of rats in student dormitory areas poses serious health risks. Rats can act as reservoirs for various pathogens that causes disease in humans. Some of the diseases transmitted by rats including leptospirosis, legumoid typhus, salmonellosis, rickettsia pox, rabies, and trichinosis. The disease can spread through direct contact with rat space or exposure to contaminated feces, urine, and water. This health implication emphasizes the need for serious attention to rat population control, especially in densely populated environments like student dormitories. In addition to the health risks, the presence of rats can also lead to economic impact through the medical treatments, costs, and the management of infection. By understanding these potential risks, preventive and control measures for rats must be prioritized to protect the health of dormitory residents and the surrounding community. Based on the research finding, the following recommendations for controlling rat population in student dormitory area are proposed. 1. Proper waste management. Effective waste management is essential, including regular waste disposal and cleaning of drainage system to reduce the environmental appeal to rats. Proper waste management prevents rats from accessing food resource and nesting sites in the area. 2. Routine rat trap installation. It is recommended to regularly set up rat traps in area with a high risk of infestation as an immediate control measure. This helps to reduce the rat population and monitor activity. 3. Education and awareness. Education in dormitory residents about rat prevention and control is crucial for raising awareness of the health risks posed by rats. This can include providing information on how to avoid attracting rats and steps to take if rats are spotted. 4. Collaborating among stakeholders. Cooperation between dormitory managers, students, and health authorities is essential to implement an integrated approach to effectively address the issue. A collaborative and sustained approach is expected to help mitigate the health risks associated with the rat presence. By applying these strategies, the risk of rat-related health problems can be minimized, creating a safer living environment for dormitory residents. The key finding from the study on rat presence in student dormitories highlights several significant aspects. 1. Spatial analysis. The presence of rat is significantly influenced by environmental factors such as temperature, humidity, and the presence of waste. These factors play a crucial role in rat activity and population dynamics. 2. Dominant rat species. The most dominant rat species one was Rattus norvegisus, which accounted for 69% of the total rats captured. This indicated that this species is particularly prevalent in the student dormitory environments. 3. Optimal environment condition at Win. Win was identified as the location with the most favorable environmental condition for rat activity. Specifically, 60% of the area had waste, and 88 of the points had optimal temperatures, and 46% of the points had optimal humidity. This condition created a conducive environment for rat movement and nesting. The findings emphasize the need for integrated rat control measures in student dormitories as the environmental factors significantly influence rat activity and population. Measures such as effective waste management, resident education, and collaboration among various strategies stakeholders are essential to reduce the health risks associated with rat presence. Focusing on high-risk areas will serve as an effective strategy for controlling rat population and protecting the health of dormitory residents. To enhance rat control and maintain a healthy environment in student dormitory based on the recent finding, the following steps are recommended. 1. Implementing the recommended rat control program. The first step is to implement the rat control measures across all dormitory, including proper waste management, regular rat trap installation, and educating dormitory residents. Effective coordination among dormitory managers, students, and relevant authorities is crucial for the success of these efforts. 2. Periodic monitoring. Regular monitoring of rat population and environmental condition is necessary to assess the effectiveness of the implemented program and identify any potential increase in rat numbers. This monitoring will help in maintaining control of the station and adjusting strategy as needed. 3. Evaluation of effectiveness. The third step is evaluate the success of the rat control program. This involves assessing the program's impact on rat population and determining whether any adjustment or improvement are necessary. Periodic reviews can help optimize the control research. For further research, finally additional research is recommended to explore more innovative and effective rat control methods for future application. Ongoing studying can contribute to finding sustainability solution to manage rat population in the long term.